So as let's talk about A-star algorithm. So A-star algorithm is basically a path-finding algorithm that is basically the best. So let's talk about how we can solve that algorithm on board. So for example, let's suppose I have a graph. So this will be a map, a 2D graph we have to this one. It's gonna have value based like 0 and 1. 0 means that the path is traversable. 1 means that there is some sort of like uh, object that is not traversable. So you have like maze like these, and you know that this path is traversable and you cannot go here. So that's what we want here. And we have this matrix and we call this a maze. So let's suppose this is a maze, and what I want to do here is we will pass the maze the starting position. So let's say this was the starting position and this was the ending position. So position will be in the form of tuples, so x and y. I'm going to pass the start position as well as the end position to our function a star. So that's what we're going to do here. So let's begin with. So let's suppose this is a maze, and I have this like 3 cross 1 2 3 4 5 3 cross 5 matrix here, and we can think of it as boxes as each that will contain data. And let's suppose these are called nodes. Nodes contain certain information. Let's suppose we make a class node. Node can contain. Let's create a constructor first. So we're gonna pass here in the constructor function. We're gonna pass mm, the parent, the position, and the value of value as f, g, and h. So what are these f, g, and h? That I'll talk about later. But parent is that what was, let's suppose this node is we are passing to a class. So its parent maybe this one or that one. So when we travel from our when we travel in a maze, so this starting node will have no parent. If we go this way, then this node, this children node, the starting node is its parent, and its position that will in the form of x and y that we are gonna pass here. So we'll pass the parent and the position, and we're gonna initialize f, g, and h to 0. These are very important, so be aware of that. So let's begin with a function. So we have a function of a star. It contains maze, the graph that we created, start and end. Those are the position of the nodes. So these are position. So what I'm going to begin with, we're going to begin with creating the nodes. So we're going to have like let's say a start node. We're going to pass parent, which is none, and the position. And similarly we're going to do the same with the end node. What we're going to do next is we're going to create two lists, open list and close list. We're going to append the open list. We're going to append the start node in the open list. So what we're going to do is open list, and we're going to add this element, add this node, append start node. So let's suppose we append the open list here. So what we want is we're going to iterate through the open list. So while open list will length of open list is greater than 0, we're going to run through this while loop, and what we're going to do is we're going to find which element has the lowest cost. So what a star works on is it takes the cost. How it computes the cost? It computes the cost based on f, g, and h. F is the total cost, G is how many nodes it has traveled from the starting node. So let's say this was the starting node and this is the current node. So how many node it has traveled, that is basically the basically how many nodes it has traveled. And then is heuristics. Heuristics is basically like, so suppose this is the current node and this is where you want to be. So this is basically the distance between this one. We can usually calculate it using Pythagoras. We calculate x minus square plus y minus y square. This is how we calculate distance for the h, and we do it is f is equal to g plus h, and based on the value of f we prioritize which way we should move, which node we should select, and everything is based on this this total cost. So far we have entered the while loop, which is length of open list is 0, and we have created two variables, open node and open index. That's going to create that's going to hold the value of first element in the open list and the index, which is 0. So it's going to hold the first element and the first index of the open list. Why we have created open list and closed list, I'm going to go come to that in a second. But we have a for loop then, which is index item in enumerate open list. What enumerate does is it gives you the index and the value the open list hold about the various element the open list has. So, and what I'm going to do is I talked about the f and the why we have total cost, why we computed. So let's see what we have to do is we have to create an if condition, and we have to see if item dot f is less than the current node. So what I do next is I have this if condition if item dot f is less than current number current dot node dot f. So if this if this cost less than the current node, I'm gonna stop. I'm just gonna set the current node value to this item value. So I'm just gonna have this current node is equal to item, and current index is equal to index. And this way I'm gonna figure out what is the lowest cost node that I have in my open list, and that's how I'm gonna prioritize what where should I move next, which node should I select first. And what I'm gonna do is after that I'm gonna run an if condition, and I'm gonna see if the current node is equal to the end. If this is end, then I have to figure out the path. So I'm going to create a list here. I'm going to run through the for loop. I'm going to say is for while current is not none. So I'm going to just figure out the parent. So current is equal to current dot parent, and I'm going to append the path dot append current. So I'm going to append the path of the current, and I'm going to just set it to the value of current to its parent. Note that the parent holds the previous position of the node. So if I were going like this, and this was the node I have, the parent, this will be the parent. So I'm going to move from this to this to this to this to start eventually to the starting node. So that's my plan, and I'm going to after that I'm going to return the path. And I'm going to reverse the list as well, so that I can have from starting to end node rather than from end to start node. That will be easy to understand. So let's talk about how I'm gonna move from my start node to the other nodes based on the value of f. So what I'm going to do is, so this is the for loop. I'm still inside my while loop. I'm going to create a children list, initializing to empty. Then I'm going to do is a for loop, and then I have a new pause in these 8 coordinates. What are these 8 coordinates, you may ask? Let's suppose we are here. There are 8 possible ways to go. So how can I move to those positions? I'm just going to do is create this variable new position, and this is my current node position. No, remember that position is in form of tuple x and y. So x will be 0, y will be 1. So what this does is this gives me the position for my node position. So I'm just going to have is the current position 0, and then the new position, this is either this one will be here. So let's suppose 0 1. So if I have 0 1, where I'm going to move? So x position is going to be same, y position is going to increase, so I'm going up. If 0 minus, I'm going down. If 1 0, I'm going right. If minus 1 0, then I'm going left. Similarly, I have other positions for diagonal movements like these. If you don't know diagonal movements, then you can remove them. I'm going to create my node position, and then I'm going to check for if I'm not going out of the box. If I'm going out of the box, then I'm going to continue. Continue means I'm going to go to the start of the loop. If not, then I'm going to have this maze. Then I'm going to index these values. So this node position I'm going to for x and y, and I'm going to check if this is not equal to 1. If these are equal to 1, that means those trains are not allowed to be move on to. So let's suppose I have this matrix, and there is some object here, so I cannot move from here to here. So I have to avoid this, so I will continue from here as well. So this is how we create children. Next thing I have to do is have a new node. I have to create the node. I will pass the object that will be the current node, that will be a parent of the children, and the position that will be the node position. So that's how we're going to create the loop and the new node. And after that I have to check if this is not in the closed list. Okay, so far we have added the new node that we have created, where the parent is the current node and the position is node position that we've got. So we will go out of the for loop where we were looking for those positions of 0 1 1 0. That loop we have going out. So here's another loop that we have to go through. So we have created a child list, and now we are going to iterate through that child list. So what I'm going to do is, so here is another loop for closed child in closed list. So you may be wondering why I created the closed list earlier. This is for the exact same reason. So what can happen is when, let's suppose I go from here to here. Okay, now when I'm here and I created the children's, this is also a path for me. So for not going into that path, I created a closed list. So you remember the first element that I created, the start node. So when I added that to the current node, so when I put that equal to current node, I'm gonna pop that out of my open list, and I'm gonna add it to my closed list. So what I'm gonna do is I'm gonna let's write it here first. So what I have to do was I have to pop that from the list, and I have to add it to the closed list. Why? Because I have already entered that node, and I don't want to enter that loop again. So for that reason I have to add it to my closed list. Closed list dot append that element. That's a start node. So once I put the start node in the closed list, I cannot go back to that closed list. Why? Because of this code. Let's write that code down. So what to do is if child is equal not like this, like this. If closed child is equal to child, what I'll do is I will continue. What continue does is I'm going to go to this loop again, to the this loop. Similarly, there is if that's not the case, what should I do? I should calculate child.g, and which will be equal to current node g. So I already told you that g is the distance travel, the number of nodes travel from start to the current node. In this case we have the children node, which will be one after the current node. Okay, so this is the current node, this is the total g we have traveled, and then we're gonna plus 1, then we're gonna add 1, and for our child. Okay, so this is how we're gonna calculate current.g. Current.g is equal to child.g is equal to current.g plus 1. Similarly for heuristics, I have to have child.h, which will be equal to let's say child dot position 0 minus end node dot position 0 whole square. So we don't have to worry about minus or positive, minus or plus. So we are going to whole square, then we're going to add with the for the y-axis as well. So child dot position 1, so x is 0, y is 1. I think that's, yeah. And for child dot minus mm, and node 1 whole square, and we don't need to underroot the value that we have got. We can just keep it in the form of a hypotenuse here. And so we have the child h, child g. We have to calculate f, that will be the total cost. Child dot h plus child dot g, and this will be the total cost that we want. So what we're going to do next is, if child dot f is in open list, after calculating f we have to see if the child is present in the open list, and if it is, we have to see if the value of g, the child dot g, is greater than or less than the open list dot g. If it's greater than the child dot g, then there is no point in adding it to the open list, because open list basically contain the nodes that we will travel next based on the cost of f as studied earlier. So we have to see if this condition is satisfied, like if child is in the open list and this g is greater, that means there's no point in adding this to our open list, and so we will continue. And if not, then append it to open list. Open list dot append uh, so let's begin with visualizing a star, and I'm gonna begin with importing pygames, then pygame.init as usual. Then I'm going to draw the window, and I'm going to keep the window size as 800 cross 800. So pygame.display.set mode, and in the form of tuple, height and width should be 800 and 800. Next thing is I need to create a function called draw, where I'm going to draw these notice maze as uh, white window, and in there these ones that are non-traversable terrains, I'm gonna keep them as black boxes, while the rest of the window will be white. So what I'm gonna do is I'm gonna iterate through my maze. So I need to create like let's say I have to have two variables, xpos and ypos, and they help us in tracking the record of the coordinates. And then I have a pygame.draw.rect. Also I need to draw a window again, because otherwise it create a mess sometimes. So I have display.set mode 800 and 800 in the form of tuples. Here I forget, so let's do it that same here. Also rect, and here I will pass the window. The color should be white, so I'm gonna have color 255, 255 and 255. And similarly I pass xpos, ypos, height and breadth. And I'm gonna do is create variable height and breadth, and I'm gonna set height equal 20 and width is equal to 20 as well. So let's set height and width here, so width and height here, and then let's increment xpos by 20. So every time I draw a box, I'll move 20 above 20 to the right, 20 steps. And what I do is, I think I need another for loop here, so let's do that, because I will just be the list of, so let's draw another for loop for chain maze. And also after once I have iterated through the first loop of the j, I will increment y pos. So after covering one complete row, so after I end up from the first row, I have to move to second row. So for that I will increment y pos by 20. And I know you can see an error here. I can't do anything because this is a recording and I'm doing a voiceover later in the video. So uh, if you spot the error, then please wait, I'm gonna cover it in a moment. So else pygame.draw.rect window, the color will be black, and if I equal to 1, so if it's 1, then I'm going to draw black, and expose y pos, and width and height. And what I'm going to do here is, so I think I should update the window, so pygame.display update, and I need to call a draw function and pass maze as well. So also I need to have a while true loop when I'm creating a Pygame window, and here I will be passing my main function. Also I should have that for event and event pygame dot event dot get if event dot type is equal to pygame dot quit, and run is equal to false. And in this way I can close the window once I run my program. Otherwise there is no option to close the window, and you have to press Ctrl C to interrupt the terminal using keyboard interrupt. Okay, so I have to increment expose here by 20, and let's see. Okay, so we have the window here, and you can see the obstacle as well, those that I have. So here you can see that we have to give the obstacle manually in the code, otherwise they won't appear. Also let's increase the size to 800 and expose y pos. Okay, so there's a mistake. I have to also increment the expose and y pos, which will be height and width, width and height here, and let's do it here as well. So let's interrupt the keyboard interrupt, sorry, and let's run the code. So now you can see here, so we have to resize the window as well manually. Later we're going to solve this issue as well. So we have able to visualize our maze, and now what we need to do is visualize the path that we get. So because I get the path, that is the solution after I go through my def a star function a star. So what I do is I'm going to do is run a for loop for path in path if a maze is equal if maze index values or to index the values. So maze path 0 and path 1, which will be the x and y position. If this returns me 3, what I have to do is when I also have to have an elif condition. Okay, so there's a mistake here. This should not be equal to 3, should be equal to 3 only. So path 0 path 1 equal to 3. So what I'm going to do is the path that I get, I have to index those value equal to 3, and I have to draw those square as green. And let's call draw function here, and there's no function called delay, so I have to cancel that one and cut that one. Let's save it, and okay, let's create the function, create the program. So pygame.draw.rect, and let's have a window, color, and expose y pos, width and height as we've done earlier, and expose plus equal width, and the color should be 0 to 55 0. I think that's green. So let's run it, and okay, so it won't yeah, sure. So here you can see the path that we have decided. Here you can also see that we have to manually give the start and the end position in the code, and that's a task for you to decide how you will be able to set the start and end position after the program has run. So that will be your task. All the rest of things I will show you. uh, so just trying few things with, and so let's keep that one for now. This looks much better. And now I want to also see the wrong path, or the how a store actually works. So let's do one thing. So when I added the elements in my close list, I'm gonna set their values equal to 2, and if I get a value which is 2, I'm going to draw it red. I think that will show me how my code is working. So let's do that. So what I need to do is create a for loop. So for I in closed list, I'm going to set maze, then I have to add the index value. So I dot path position 0, and similarly I dot position 1, and I'm going to set the value equal to 2. And if the value is equal to 2, in my draw function I'm going to say that let's draw rect and pass the color red. So let's copy paste this one. If j equal to 2, if a value is 2, I'm going to set the color, I think it's 25500, that's red. So let's save this and run. Let's see if it works or not. So I think I should press Ctrl C and run the code. I think it should work. Okay, so it's working, and it's giving me the path as well. So now you can see how the A star actually works. Now let's add some more functionality to our code. So what I'm going to do is I'm going to remove all this code, and I'm going to start fresh. I'm going to create a variable false, and I'm going to call draw maze function. I have actually moved my maze upwards to the top to set it as a global variable, and I'm going to create a for event in pygame.event.get for the mouse. I'm going to look for mouse events. So if event.type is equal to pygame.mouse button dot down, I'm going to get the position. So as you can see, I have set get pos equal empty tuple. So I'm going to get the position of my mouse coordinates. I'm going to set the where variable equal true. If the where variable is true, I'm going to run two for loop condition 0, 7, 20 and 80, and again for j in range 0, 7, 20 and 80. If I get pos I is greater than, less than equal to I, and I plus 80 is greater than equal to get pos 1. I think there's a mistake in the code, so it should be 0, 0, 1, and similarly get pos 1. J plus 80 should be okay. So there's a obviously mistake as well. Get pos should be 1 there as well. If I get that, I'm going to index my values to 1. So I have actually set an empty matrix. I mean all the values in my matrix is 0 this time. That maze one. And what I have done is when I click on my maze, I will set the particular box to 1, and I'm going to setting the start and end values as usual. And for event dot pygame dot get, if event dot type is equal to key down. So if I press space bar, I'm going to start my a star function. So path is equal to a star maze start end for path and path. If maze path 0 and path 1 is equal to 3, I'm setting equal to 3, and let's call the draw function here and see if it works or not. So let's call the function here, run the program here. So so it has got an error here. Okay, so there is no mouse in this mouse button, so let's remove that and run the code again. So if I think there's a mistake here. Okay, so that should be 1, and let's run the code. And now okay, so there's another mistake this time. What's that? Oh, j plus 80 should be greater than equal to get pos. That's a mistake this time. So let's change that and set it greater than equal to get pause and run the code. And I think it should work now. This third time is a charm. So okay, so this is working, and now I can draw my obstacle as you can see on the screen. So I know this is not the best way to visualize A star algorithm, but let's see how it works. Okay, so this gives me the path I want, and I hope you like this video. If you like this video, subscribe, press the bell icon, and I hope I see you in my next video. Peace.